Hi guys, today we're looking at proportional relationships, tables, and equations. And if I don't get to finish this entire lesson in this one video, please watch the second video that correlates with this. So you are looking at the new format of the workbooks and textbooks that we're going to be receiving. This is just how it's kind of set up. So this is what your note page looks like for today. We're going to go back to the old notes. I just wanted to show you kind of what this looks like. And then your essential question that is right here is essentially your learning target. So when you are looking for your learning target, that is kind of found right here. Okay, so let's go ahead and dive in. Your first section right here is always explore, and this lesson doesn't necessarily tell you how to do this problem. It just kind of asks you to use what you already know to figure out the answer to this problem. So the first question is, a giant tortoise moves at a slow but steady pace. It takes the giant tortoise 3 seconds to travel 10.5 inches. So you are supposed to use this bar diagram to help you determine how many inches the tortoise travels in 1 second, in just this box right here. And then it's asking you, what operation did you use to find the answer? So you've got 10.5 seconds for the 3 seconds that this whole bar is broken into, and then they just want to know this 1 second right here. So what do you need to do? What operation do you use? Remember, operation is multiplication, division, addition, or subtraction. So which one are you going to use? If you said division, you're correct. So if you are trying to divide that 10.5 seconds amongst, oops, that's supposed to say division. If you're going to divide the 10.5 seconds amongst these 3 boxes, you're going to need to divide to determine how long he went in how far he went in 1 second. So let's go ahead and do that. And then what are we dividing by? Does anybody know? It'll be 10.5 divided by something. Well, they said he went 10.5 in 3 seconds, but we only want to know how far he went in 1. So we need to divide by 3. So 3 goes into 10 3 times. 3 times 3 is 9, minus 1. Bring down your 5. 3 goes into 15 5 times. Bring up your decimal. So 3.5 is our answer. So in 1 second, he went 3.5 inches. Okay. All right, so then that's what they're asking you to do in this table. They're saying, in 1 second, how far did he go? Well, we just figured that out. He went 3.5 inches. In 2 seconds, how far did he go? Well, he doubled his speed. So 3.5 times 2 is 7.0. Okay, and then we know that he went in 3 seconds, he went 10.5 inches. How far did he go in 4 seconds? Well, you can do 2 things. You can add 3.5 to 10.5, or you can do 3.5 times 4, because he went 3.5 seconds every 4, or 3.5 inches every 4 seconds, or every 1 second. So we need to multiply that by 4. 3 times 4 is 12, plus 2 is 14. Move your decimal count over 1 time, so count over 1 time here. So he went 14 inches in 4 seconds. And then if you did the same thing again, you go ahead and fill in this chart for 5. How far did he go in 5 inches? All right. So now it's asking you, for each column of the table, find the ratio of distance to the time and write each ratio in simplest form. I'm going to actually change my color so we can see it a little better. And so we've got, in this one, they're asking for distance over time. So we're not going to do time on top of distance. We're going to do distance on top of time. So distance would be, how far did he go in this first box? He went 3.5 over 1. And that just reduces to 3.5. That's why this little gray box is here. Then this one's asking us for 7.0 over 2. And what does that reduce to? Well, 7.0 divided by 2 is 3.5. And then what about this one? 10.5 divided by 3, or 10.5 over 3, it still simplifies to 3.5. You go ahead and fill in this fourth one and this fifth one on your own. And now for D, it says, what do you notice about the ratios? And this word notice is going to be in almost all of your homework assignments from now on. They are asking you to figure out what you realize while you're doing this and what you kind of understand as you're doing this. Do you see a pattern? Do you see something that repeats? That's something that you're going to be noticing when you're looking at these kinds of problems. So what do you notice about these ratios? What do you notice? What I notice is that they all simplify to 3.5. So I would write something like they all simplify to 3.5. But you might notice something different. So you can put whatever you notice about the ratios here. The only thing is when there's questions, I want you to give me at least one full sentence, because eventually we're going to have a lot more writing in math, and I want you to get used to writing at least one full sentence whenever you're answering a question. So I don't mind what you write for this answer, just write one full sentence. And then a conjecture. We've talked about this before, I think, in this class. A conjecture is another word for a guess. And if it's a guess, you can't be wrong. So just make a good guess and see what you think. So how do you think the distance a tortoise travels is related to the time? Related, that means how is it correlated? How does one affect the other? So how do you think the distance the tortoise travels is related to the time? So again, on this one, this is a question. You need at least one full sentence, a capital at the beginning, a period at the end. And then you need to tell me what you think. How is the distance the tortoise traveled related to time? Okay? All right, and then these two questions kind of carry on with the same thing that we were just learning, and I want you to do them on your own. This is kind of like your practice for today. So I want you to do 1A and 1B, and then this one is, how would you describe the rate or speed at which a tortoise travels? This is talking about if it's fast or if it's slow, or if it's average or something like that, okay? So you answer 1A and 1B. Pause the video now to do that, and then I'll come back with your next page in just a minute. Okay, and then here is the second page of your notes, and this is where anytime you see a word that's kind of highlighted like this is your definition that I typically have in the side columns. And like I said earlier, we're going to go back to my old notes. I just wanted to show you kind of what these new books look like. So this is a proportional relationship. It's a relationship between two quantities in which the rate of one quantity to the other quantity is constant. Okay, so a giant tortoise can live as long as 150 years, and one reason that these reptiles live so long is because of their slow heart rate. A giant tortoise's heart beats only 6 times per minute. The giant tortoise's heart rate is an example of a proportional relationship. So it's something that's constant. It's always going to beat 6 times per minute. See if you can, on your own, just think of something else that is another proportional relationship. Our heart rates are not proportional relationships because we can run and they'll get faster. We can maybe be really tired and they'll beat a little slower, things like that. So our hearts are not proportional relationships. But what is something that might be a proportional relationship? Think about it, and if you get an idea, write it up in this top corner. All right, and then this second example is to identify a proportional relationship. So this is Alberto types 45 words a minute. Is the relationship between the number of words and the number of minutes a proportional relationship? Why or why not? Okay, so when they're asking you, is the relationship between something, they will tell you the order on, basically you just need to look at this order to know which number goes on top and which number goes on bottom. So this is what I'm talking about here. If it tells you the relationship between the number of words, words is listed first, so words is going to be on the top in the numerator, words, and minutes is listed second, so minutes will be listed on the bottom, minutes. Okay, so they're asking for words to minutes, and they will always ask you in order of how they want it, top and then bottom. All right, so let's go ahead and look. So the number of words we're doing in green, and so your number of words, he does 45 words in 1 minute. How many does he do in 2 minutes? Well, you might just be able to see that he'll do 90. And then how many does he do in 3 minutes? Well, we might need to do some math. 45 times 3 is 135. Do you see how I did that? Now you can go ahead and do 4 and 5 on your own. Find out how many words he types in 4 minutes and find out how many words he types in 5 minutes. And then once you finish that, we're going to move on to section B to complete these ratios. So the number of words over the number of times, which is exactly what I wrote up here. Number of words is in green and time would be in purple. So the number of words for this first one, they gave you this first example right here is 45 to 1, which is this one. So now we need to do these other 4 in these 4 boxes. So this one is number of words is 90, and how many minutes did he take to do 90 words? Well, it took him 2 minutes to do 90 words. So then the third box is 135 words, and how many minutes did it take him to do that? You can look at your chart and see that it was 3 minutes. So then you need to take numbers 4 and 5 and fill those in together. And then you need to look at the 5 ratios that you just wrote right here and figure out what they all reduce to. What do they all simplify to? And that's just working with fractions. You just need to see what does 90 over 2 reduce to? What does 135 over 3 reduce to? What does 45 over 1 reduce to? I'll give you a clue. It starts with a 4, but it's a 2-digit number, so you need to find out what that next number is. Okay, and then it's asking, this next line, it says the ratios are blank. Well, we just looked up, we were up here, they're asking us about proportional relationships. So they're asking you here, are those relationships proportional? Do they all relate to each other? Do they all have a common number that they all simplify to? If the answer is yes, you're going to say the ratios are proportional. And then right here it says the common ratio is something. So what was our common ratio here? Well, it was 45 or 45 over 1, because that's what all of those other ratios all simplify to 45 or 45 over 1. And so you would say, so the relationship is proportional. Okay, so that finishes up this section. And I only have about 1 minute and 10 seconds left till this video is over. So what I want you to do is try section 2A and 2B on your own as practice right here, and then 2B right here, and they're about the same, they're the same exact kinds of problems, and 2B is talking about 2A when you get to that. So go ahead and do those, and then I just have one more page to go over with you, and that is going to be on the second video. So I am going to need you to watch this next video, but it won't be a 15-minute video. It'll just be a couple minutes. Okay? So finish these 2 practice problems and then watch the next video as well.